All right, Lab 5, atmospheric moisture, and today we're going to walk through some of the problems that we're going to have for Lab 5. And the first one is a reminder on latent heat. We're going to talk about solid water going to liquid water going to gas. And if I go from a stage of less active to a stage of more active, I have to consume energy. And if I go from gas to a liquid to a solid, in order to go from a state of more energy to less energy, I have to release that energy. So I have consuming if I go from less active state to more, and releasing if I go from a more active state to less. And what that means for the cloud around it is if I'm going from a less active state to a greater active state, I'm going to make the cloud cold. Where if I'm a gas going to a solid, in order to release that energy, I'm making the cloud around me warm. And that's going to play into our lab activities. The other part that we need to review in order to do the lab properly is that saturation curve that we learned when we were talking about humidity. And in our book, we have a layout of a saturation curve where you have mixing ratio on this side, which is in grams per kilogram of air. And down here I have temperature, which is in degrees Celsius. And on this curve, what it means is that everything below this is unsaturated air, which means I have capacity for more water, and evaporation is greater than condensation. Everything on the curve, evaporation is equal to condensation, and that is saturation. And everything above the curve is supersaturation, and condensation will exceed evaporation. So if I want to know the saturation mixing ratio, if I know the temperature, I can take that temperature up to where it meets the curve. So if I say 0 degrees Celsius, and I line it up, and I put my spot to where it hits the curve, and I slide it over to my y-axis, I can read off my answer, and for 0 degrees Celsius, my saturation mixing ratio, my maximum amount of water I can fit, is 8 grams per kilogram, or the answer here at 8 grams per kilogram. All right, now we're going to talk about using a saturation mixing ratio into an equation to find relative humidity.